So dear ladies and gentlemen, let me give a short introduction. We have today a distinguished guest, Professor Vairavamoorthy from London office of the IWA. Professor Vairavamoorthy is the Executive Director of the International Water Association. He is a globally recognized expert in water resource management with focus on urban water challenges. He pursues an extensive collaboration with the World Bank, so very large organizations like the World Bank, UN Habitat, UNESCO, EU, CV, and GVP. Formerly, Professor Vairavamoorthy served as Deputy Director General for Research at the International Water Management Institute, driving global water security and sustainability research. Professor Vairavamoorthy is a real academic person. He fulfilled a lot of highest ranked academical rules, like he was founding dean of the Patel College of Global Sustainability of the University of South Florida. Furthermore, he fulfilled very high ranked posts in the UK and the Netherlands. Like he served as chief professor at the University of Birmingham, EIHA UNESCO, and the TU Delft. Professor Vairavamoorthy is active member of international scientific committees and holds PhD and MSc from the Imperial College in London. Moreover, his bachelor he obtained in the King's College in London. Let me shortly introduce the International Water Association. The International Water Association is the largest water association in the world, comprising more than 10,000 individual members from more than 140 countries. The mission of the International Water Association is to promote sustainable water management worldwide. At the same time, the International Water Association is a knowledge hub which publishes leading journals. I would mention here the journal Water Research with an impact factor number of 12.4, which is the highest ranked water-related scientific journal. Furthermore, state-of-the-art books, guidelines, and so on. The big value of the International Water Association is that it connects science, innovation, and practice. The IWA supports research, technology, and practical solutions. And hence we are at a university. I would like to highlight that the International Water Association gives a lot of opportunities for students, like access to resources, conferences, and career networks. So please use these networks. Hungarian contribution to IWA. I would mention here two outstanding personalities. Firstly, I would mention Professor Pál Benedek, who was one of the founding fathers of the IAWQ, which was the ancient IWA organization. Furthermore, he was a co-organizer of the first large wastewater treatment workshop in Vienna, 1971, alongside with professors like von der Emde from Vienna, Eckenfelder, and so on. A further personality I would mention my predecessor as head of department, Professor László Somjódi, who among others even served as president of the IWA from 2004 until 2006. How we came to this visit? Thank you, Kala, for accepting our invitation. We organized an extraordinarily successful IWA conference last year, 2024 in Budapest, which was really a big success in a very good atmosphere, as you can see in the pictures. This conference included more than 300 attendees, 35 plenary presentations, 8 keynote presentations, 8 workshops, a lot of site visits, and a variety of cultural programs. The largest event of the IWA is without doubt the World Water Congress, which I would like to mention here. The World Water Congress is organized in every 2 years and includes more than 10,000 attendees, so it's a very big event. The past venues were very prestigious cities in the world, like Copenhagen, Toronto, Glasgow, Kuching, which will be in 2028, and Sao Paulo in Brazil. And we have an idea, why not in Budapest 2032? So, thank you for your attention, and I would like to ask our rector, Professor Sharaf Hassan, to hold your address. Thank you very much.
Dear Executive Director, dear State Secretary, dear CEOs and presidents of companies, dear colleagues and students. Professor Vairavamoorthy, thank you for coming and for accepting our invitation. We are happy to host you here, and we are proud of you. BME, as I mentioned in the small meeting, it's not a young university. We just opened on September the 244th academic year. So this university was founded in 1782. And one of the first competencies in this university was the water management. So water management is not new in this university. Why? The need also is given because Carpathian Basin is a region where we have a lot of flood prone, we have a lot of water, and we should deal with these challenges. And the younger generation know that every year in Budapest we have a challenge with flood and flood protection, and we need more and more research and development for innovative solutions for water management in general. Of course, BME is not only about water. We have 8 faculties. We cover all the parts of engineering, plus natural sciences and economic studies. So we are a multidisciplinary university, but the main focus is engineering. And we are happy to cooperate with international associations. I was happy to listen to you when you mentioned that the student section will be founded in Budapest. We are happy to hear that. Here, the 3 players, the academia or university, industry, and the government, I can say are good together in this place, and we are proud about our industrial partners because we have everyday relationship with them, not only for shipping the best talents for them, but also to do R&D activities together and to develop new solutions. Again, we are interested to listen to your talk. That's why, again, welcome to Budapest, welcome to BME, and we are happy to host you later also, and to have in 2032 challenge to have the World Congress in Budapest. Thank you for coming.
Dear Kala, if I may so, I would like to ask you to hold your presentation.
just get this going. Okay, so good morning, everyone, and can I just say it's really a great honor for me to be here with you today. I've been to Budapest many times. This is the first time I've been to the university, so special thanks to Professor Miklos, the rector of the university, Professor Hassan. So far, my engagement here at the university has been really fantastic, and I always love coming to Hungary because the hospitality is second to none. So it's really a great pleasure to be here. I keep notes so that I don't digress and talk for 2 hours, so bear with me. But my talk today is really to share with you my thoughts on how our sector, the water sector, is transitioning to a new normal. And this transition that we're seeing within our sector is really in response to some of the global change pressures that we're facing, and I'll talk about that in a minute. Oh, sorry, my slide. Sorry. Can I get my slide deck?
Yes, of course.
Sure. Okay, yeah.
All right.
It's not coming up. Facing these global change pressures, and so what we see in terms of the transition is we're moving to more circular approaches where we're using water multiple times, where we're trying to recover value from our waste streams. And we're using more solutions based on nature. And what I also see happening within our sector is a move to more sort of decentralized or distributed systems and away from the sort of hardcore centralized systems. Now, this transition that we're seeing within our sector really requires a level of leadership and innovation that's unprecedented in the history of our sector. And what I hope that you'll take away from this talk is very simple, that leadership matters, and your leadership, particularly the young people in this room, you're the ones that are really going to make this change. And you have that sort of creative spirit that's going to allow us to make this change. So, as I said, our sector is under pressure from every direction, and I don't need to sort of go into this in too much detail. Climate change, of course, is bringing more droughts, floods, and unpredictable weather patterns. Urbanization is actually also very, very interesting because it's driving up the demand for water and wastewater services. By 2050, it's predicted that 2.5 billion more people will live in cities, and most of them will be in the developing world. And what's interesting about this migration or urbanization is that these people in the global south, they're not, the numbers are not just increasing, right? The numbers aren't just growing, but the people are actually growing up, which means their living standards are improving, which means the rate at which they utilize water is also increasing. So you have cities where the numbers of people are increasing, the amount of water that they consume is increasing. So the demand is increasing sort of exponentially, if you like. But on the other hand, climate change means that the water availability is going down. So potentially we have this big supply-demand deficit, and we ask ourselves, how will we deal with that? At the same time, many utilities all around the world, here in Hungary as well, have aging infrastructure. We have leaking networks, outdated treatment plants, reservoirs that are long past their design life. So that's a big challenge for us. How do we modernize our infrastructure in response to some of these changes? And then we have much tighter environmental regulations and targets that are putting challenges on the water sector. We have big net zero goals, right? And then the question is, how do we respond to that? Because it puts more pressure on us, and it also results in more cost. So together, these forces mean that we must adapt fast. We have to modernize our infrastructure, we have to improve our efficiency, we have to cut emissions, and we have to rethink how we use water, how we reuse water. These pressures are very real, but so are the opportunities to build something bigger and better. Now, if we take mitigation as an example, right, this is one of the things that the utilities have to respond to, and this is a very complicated challenge that we find. Implementing low-carbon solutions isn't cheap. It requires major capital upgrades, staff training, and sometimes higher maintenance costs in the early stages of deployment. So it's costly. But the bigger area that we're struggling with as a sector is how we estimate these emissions accurately, particularly from our wastewater treatment processes and the associated fugitive emissions. We have a lot of emissions in our wastewater processes that are leaking, and they leak fairly potent emissions, things like methane and nitrous oxides. And our understanding of how much we're emitting is very, very poor currently. The science in this area is still evolving, the data is limited, and the numbers are very uncertain. So when our estimates are uncertain, it becomes quite hard to justify major investments or to explain the value of those investments to our stakeholders. Now, on top of this, and I'm sure all of you watch the news, if you throw into the mix the political uncertainty that we face, where many governments, due to economic pressures, energy security issues, and social pushback, are softening or delaying their net zero ambitions. This creates another dimension of complexity. So this makes it a very challenging environment for us in trying to respond to mitigation in a very confident way and to make long-term decisions. But I want to emphasize mitigation is essential, but the pathway forward will demand flexibility, resilience, and smart thinking. Now, given all the complexity, most of the innovation that we see in our sector is focused on making our treatment systems more efficient, especially through something we call intensification. Intensification is where we try to deliver the same treated water quality outcomes, but do that with less energy and do it at a much smaller physical footprint. And there are lots of innovations in this space, and you see some of them on this slide. Carbon redirection is where we use new technologies to remove more organic matter in our primary settling tanks. That's before we go to the bioreactors. And this means that if we do that, then we have lower organic loading rates in our bioreactors. And this allows us to increase the throughput through those reactors and reduce the energy requirements. So we get improved performance at a lower energy footprint. That's intensification. If you look at aerobic granular sludge, this changes the physics of our settling processes of our sludge. AGS particles are denser, they're more compact, and this leads to better solid-liquid separation. And this allows for smaller clarifiers, these are the secondary sedimentation tanks, and higher throughput through these clarifiers. So again, it's intensification. If we look at something like thermal hydrolysis, this is where we pressure cook our sludge, and that reduces the viscosity of the sludge. So again, it's something that changes the physics. And then we can improve our sludge loading rates into our anaerobic digesters, and we can generate more energy. So these types of innovations are becoming very common within our sector in response to some of these issues. And they allow us to implement systems with lower energy, lower footprint, which means ultimately lower capex costs and opex costs. But here's the paradox, right? And I think it's important for you to understand this paradox. Reducing energy does not always mean that you reduce your emissions. Some of the innovations around intensification have unintended consequences, particularly in terms of emissions. So one of the examples I showed on the other slide, which I intentionally didn't talk about, was Anamox, right? And this is a process for nitrification and denitrification in our wastewater treatment processes, and it saves a lot of energy. So you think at first hand, this is very good because it saves energy. But this process can sometimes unintentionally generate nitrous oxides. And nitrous oxides are 300 times more potent than carbon dioxide. So in other words, what looks like an energy-efficient process might be very inefficient in terms of its climate impact. So when we talk about low carbon or net zero, the focus has to be on greenhouse gases and not on kilowatt hours saved. And the interesting thing that you see now, and it's a bit counterintuitive, but in some cases, actually using more electricity, particularly if it comes from renewables, may actually lower our carbon footprint. So if our electricity is renewable, and we're seeing a lot of that in the water sector, that means our Scope 2 emissions are coming close to zero. And that's making the case for more energy-intensive processes in our treatment, because it reduces the potential for some of these unintended consequences in terms of things like methane and nitrous oxide. So the message is very simple. As we innovate, we must take a holistic view, considering the full greenhouse gas footprint of our choices and not just the energy savings. And I can tell you, in my sector, we're just coming to grips with these types of issues now. It's challenging for us. So while we cut emissions, we also need to ask ourselves, how can we build systems that are flexible and robust so that we can manage what happens next, right? So this is where adaptation comes in. It's the other side of the coin, if you like, in the climate discussion. When we talk about adaptation in the water sector, I see two important pathways that stand out. The first is around the productive use of water, and the other is around the circular economy. Productive use means thinking about what is it we want the water to do for us, and how can we match the quantity and the quality of the water to that intended use. And this moves us away from the thinking that we need high quality water or high quality drinking water for everything. Of course, drinking water must be pristine, but for flushing our toilets, for irrigation, for cooling, we can use lower grades of water. And what this allows us to do is to use water multiple times in a cascading way, hence maximizing the productivity by doing more with less. On the other hand, circular approaches focuses on reducing waste and reusing as much of our resources as possible. For businesses and industry, this means managing water in a way that boosts their resource availability and ensures long-term operational stability. It's really about improving the supply chain resilience of their operations. Now, a great example of the productive use of water is the West Basin Initiative in Los Angeles in California. And this was developed in the 1990s to deal with water scarcity. And what they do is they take the wastewater from the city of LA and they create what they call designer waters, or waters of different flavors. And they use different plug-and-play technologies to create these different grades of water. And they can change these treatment trains as of when they want to and create different quantities of these different grades. So you have one grade for irrigation, a different grade for cooling, another grade for use by industry, and then another grade for AAR, which is artificial aquifer recharge. It's where we recharge the groundwater. This is really a very great example of advanced reuse. And it shows us really the power of productive use thinking. Because we're using the same amount of water, but because we're cascading that use of water, our overall water footprint goes down. And so these types of approaches, they challenge the old assumption that most utilities have, which is that if we've got a growing demand for water, we need to take more water from the river or aquifer. These types of approaches, and also an approach called integrated urban water management, pushes you to look at efficiencies embedded within your system. So reducing leaks, implementing demand management, capturing rainwater, All of this avoids you having to build new infrastructure to move water long distances, because you're investing in efficiencies from within your system. And the outcome of some of this thinking is you start to develop what we call a portfolio of sources. You have many sources of water that you can depend on. A great example of this is in two cities, and we were just having a chat earlier about Singapore. Singapore is very famous. It created what's called the 4 national taps, and I don't think you can see it very clearly. But Singapore depended a lot on Malaysia to supply its water. And Malaysia used to threaten Singapore that we will close the tap if you behave badly. So Singapore was always at risk. So what they did was they started to create new sources of water to diversify that risk. They built a reservoir, the Marina Barrage, which captured stormwater. They then invested a lot in desalination. And then they took wastewater and treated it and created what they call new water. Right? And what that means is that if one of these taps dries, they've got 3 other taps to depend on. And so this is quite a famous example, but the more interesting example is in South India, in Chennai, where they've got this approach called the Aru Kudams, or 6 pots. It's very similar in concept to Malaysia. And they had an extreme drought in 2019. And so they invested a lot in diversifying their sources. So they have their surface and groundwater. They also have quite a lot of desalination taking place. They use a lot of treated wastewater to support their industries. They invested a lot in rainwater harvesting at cluster level. This is at sort of apartment block level. And of course, water conservation. But one of the interesting ones was they looked at their quarries, the disused quarries, and they used them as rainwater harvesting sites. And they used that water to recharge groundwater through infiltration galleries. Now, of course, it's polluted water, right, because it comes from industry. So they're looking at using things like constructed wetlands to treat that water before putting it into the ground. So again, they created these 6 sources of water that meant that if one of their sources dries up, they could depend on these other sources. So it's this diversification or a portfolio of options. So reuse of water and cascading it is really now rising, and it's not just at the margins anymore. It used to be a niche area, but now it's becoming mainstream and strategic. And it's the main response that you see to water scarcity challenges worldwide. And here, we've just seen some examples, but the challenge here is that, you see, the technology is ready. We know how to do this sort of thing, right? But there are challenges with things like cost recovery. The tariffs that you get from reused water doesn't cover the cost of your investments in infrastructure to sort of build these things. Also, reuse delivers lots of other benefits like resiliency and environmental benefits, but these are very hard to monetize, and they don't fit nicely into our financial models. So we know that there are all these external benefits that you get from doing something like this, but we're not able to articulate that in a cost-benefit analysis. So the next frontier in reuse, and we're doing a lot of work on this in IWA, is not in the technology realm. It's more about the sort of sustainable financial models, the regulations that are needed to encourage people to move in that direction, and also trying to increase public trust. But it's not just about grey infrastructure. There is a growing interest in nature-based solutions, especially as climate adaptation tools. And they're already used widely in water management, and I saw yesterday with Miklos some green infrastructure here in Budapest. So they're being used from source water protection to urban drainage to flood control and even to wastewater treatment and reuse. And in this slide, this was work that I was doing when I was involved in a big European project where we're closing the loop of the water cycle with nature-based solutions. Now the public, they love these systems. People prefer green spaces around them rather than concrete. Engineers like concrete, unfortunately, but normal people like green spaces, right? But for engineers, these systems create a lot of challenges, because the science that underpins these systems is still in its infancy. These systems are often unpredictable, and they experience a lot of seasonal variability. We see this in countries where you have, hot and cold. Like in Canada, we did a lot of work where we couldn't really say how these systems were behaving in the winter. And it was very difficult to understand what sort of processes were going on when the season changed. Also, there isn't clear guidance on how to design these systems. We tend to use rules of thumb, right? So, and the other point is that the benefits that these systems provide, huge benefits like biodiversity, cooling, recreation, they're very real. But just like reuse, they're very hard to monetize. And again, they affect our ability to articulate the cost benefits of these systems. At IWA, we've established a task force trying to develop the science, because from our point of view, these systems will be the future. But we just need to better understand the science that underpins them. And we need to have better ways of valuing all these additional benefits that these systems bring. Now, one of the most exciting global conversations you see in water right now is around resource recovery, turning what used to be wastes into products with real value. And again, I travel a lot around the world, and in the developing world, in the global south, these approaches are very interesting because they're building a lot of new infrastructure. They're building this sort of stuff at the design stage itself, not like in the global north where we sort of retrofit. They're actually from scratch hardwiring these types of approaches. And they're hoping that these types of approaches will provide revenue that will help them sustain their operations, which have been very difficult to do. So we see a lot of technology in this space, right, where you can recover things like biogas, biofuels, nutrients such as phosphorus for fertilizers, and other products like biopolymers for plastics, sulfur compounds for battery production, etc. But here's the thing, right? The technology is advancing. We're doing a lot of work in that space. But our understanding of the markets, the business models that support these systems is lagging behind. We still know very little about the profitability of these products. Who will buy them? What will be the supply chains that will keep them going? Most of our focus in this space has been around developing the technology. It's not been around understanding the customers for these products, the value chains and the cost structures. So we're not at the point where resource recovery is really making a strong business case, not yet. But it clearly is the direction of travel of our sector. Something that's really quite interesting that I've seen in the last few months, and we had a big event recently in the Netherlands that I spoke at, was that we're seeing a new generation of resource recovery pathways. And they're enabled by advanced separation technologies, electrochemical processes, and biologically tuned production platforms. And what's also interesting is that there's this shift away from high volume, low value products like biogas to targeting low volume, high value products, right? And so people are now sort of saying, well, we might be able to get a little bit of something, but it's very, very valuable. So for example, Vivianite can be magnetically separated and used as a high-value pigment or as a phosphate source. Lithium and magnesium can be recovered at battery-grade purity from desalination brine. And short-chain fatty acids like acetate are emerging as valuable chemical intermediates, worth many times more per unit of carbon than something like methane. What's really interesting, and in this meeting we had in the Netherlands, it came out, was that pursuing these high-value products by design could completely reshape the treatment trains that utilities currently have in their business models. We could see a move away from simply treating wastewater as our primary focus goal to thinking more about running precision recovery platforms that create these speciality materials and new revenue streams, where the wastewater treatment process is almost like the side hustle, you know, it's a side business. Right? You're doing that, but really your focus is in trying to recover some of these high-value products. However, as I said earlier, success depends not on technology alone. Each recovered resource, if you're a utility and you want to recover some resource, each resource you're trying to recover comes with its own technical demands, its own costs, its own market realities, and its own supply chain needs. So a utility shouldn't and mustn't try to chase every possible product that they see potentially that they could recover. They have to choose a lane. They have to say, I think this is the one that I could probably recover, and then focus on that. They have to be strategic in choosing that resource recovery pathway, and the markets have to align with their own local context and the industries that they have around them. And that's the important thing. They need to understand their local industrial ecosystem for the recovered products. And they need to then build relationships with the off-takers and the processors and the end users. The winners in this space won't be the utilities that try to do everything. The winners will be the ones who focus on targeted recovery pathways, build the right industrial partnerships, and create viable business models around recovered resources that make sense for their region. And this, in this meeting we had in the Netherlands, it was quite challenging for some of the utilities to think in this way, this idea of choosing a lane, focusing on one product, and understanding their industrial ecosystem to support it. Now, I want to talk a little bit about a pet topic of mine. It's something that we've established quite a lot of thinking at IWA. We're working with Berkeley, UC Berkeley and ETH and Ghent. And this is around this shift from sort of highly centralized systems to decentralized or distributed systems. In my view, if we're serious about reaching everyone with sustainable water and wastewater services, we have to rethink how services are delivered and who delivers them. And what we're finding is that decentralization opens up new opportunities. It allows the private sector to get involved in service delivery. It can drive innovation, and it can create more cost-effective solutions that are very much tailored to the local context. Now, other sectors have shown that this is possible, and that's what this slide is demonstrating. And we need to take some inspiration from these other sectors like energy and communication. On my travels, right, it always amazes me that when I go to a low-income area, a slum, for example, where people are still defecating in the open, they're still shitting in the open, right? They don't have sanitation facilities. Those people, they have a mobile phone. But what's interesting is not that they have the mobile phone. It's that they have the ability to charge that mobile phone in their area, right? So in this very difficult environment, the infrastructure is in place where they can actually charge these devices. And that's what, for me, is very strange, because I wonder, why can't we provide water supply for these people? Why can't we provide sanitation? But yet these other sectors are providing all these other services. And I always ask myself, how did these sectors achieve these outcomes? They've moved much further and faster than the water sector. See, in my view, these industries have shown agility by providing technologically agnostic solutions and embracing decentralized off-grid systems. And this is something that we can definitely learn from the water sector. So can our sector start looking at decentralization as a tactical opportunity, an ability to be nimble, frugal, and speedy? You see, traditional centralized systems are cumbersome and heavy, and they require a lot of effort to get them moving. Lots of planning, lots of land approval, a lot of money, a lot of time to implement. And all this leads to delays and procrastination. And I see this a lot in my travels, particularly in the Global South. In contrast, decentralized or distributed systems have a certain agility. They can be rolled out in stages and at a much faster pace. And right now, we're seeing some really interesting innovations in this space. I mean, we're working very closely with the Gates Foundation, right? You know, Bill Gates' foundation. And we're building these decentralized water machines that can create waters of different grades and can treat everything within an apartment or within a house. And you never have to be connected to a sewer. This is the direction of travel that we're seeing. So, if you take a traditional urban area, right, and this is a little bit of history, so you'd have an urban core. So, in countries like India or in countries in Africa, there'll be an urban core, and there'll be a centralized infrastructure system. Now, traditionally, what we would do is we would extend that core, right? So we would extend the centralized system, and we'd create sort of a spaghetti network. That doesn't work. But now the thinking is, what if we were to ring fence that centralized core, and we were to sort of build these decentralized modules that actually map the way in which the urban growth takes place. So rather than us trying to anticipate how growth might take place, we actually start to map it so we can follow the pattern of growth. And it allows us to phase in or stage our investments, right, over time. What we can also do is be technologically agnostic. There's lots of innovations in decentralization. So we might put a certain type of technology in a low-income community and a different technology in a high-income community, but the outcome will be the same. They all get safe, equitable water supply and sanitation services. And this is what the solar industry does, right? They create different types of solar technologies for different types of communities with different price points. So what if, you know, these decentralized approaches move away from one size fits all to allowing you to be technologically agnostic. The other thing is that these systems also better promote the circular economy narrative. You know, water is very heavy. And when we talk about reuse in a centralized system, we use the water, we move it long distances, we treat it, and then we move it long distances back. And that requires a lot of energy. Whereas with decentralization, the resources are being generated very closely to where they're needed and where they can be used. The other interesting part of decentralization is that when there's a failure, when there's a flood or something, it doesn't wipe out the entire system. You can contain that failure within a module. When you look at a lot of the extreme events that happen, centralized systems get wiped out, right? And it's very common that water or wastewater treatment systems get knocked out because they're centralized. But with these sort of decentralized approaches, you can sort of protect the rest of the system by containing that failure. So they have this sort of natural ability for resiliency as well. So as I said, in IWA, we're doing a lot of thinking around this. There are still many challenges in terms of how you operationalize them, what would be the costs associated with this. But it's an area that a lot of thinking is now going on, and particularly in many countries in the global south, this is being seen as the preferred option to move forward, not to have large networks of sewers and pipelines. And you've got some very good examples of this already around the world, and you can see some examples here. If you take Oceansharm in Sweden, they've reduced their water footprint by 50% through closed-loop thinking. Their black water and their food waste are co-digested to produce fuel for the local buses, while grey water is used to generate struvite, which is a phosphorus-based fertilizer. And their treated sludge is also repurposed as a soil conditioner. So they're creating value from all of their waste streams at that sort of decentralized level. What's interesting is if you look at, say, Battery Park in New York, right? What drove this was not some religion about decentralization or anything like that. It was a very practical need because in the city of New York, they put a requirement that new housing developments cannot connect into the sewer. There isn't enough capacity for the sewer to take the wastewater that's getting generated from these big apartments. So new apartments now have to have these water machines within their apartment, so that the amount of load that comes to the sewer is minimized. So it's being driven much more by planning regulations. In the global south, we're seeing it being driven much more by water scarcity. And in IWA, we've just launched a new initiative called Water Efficient Sanitation, and this is where we use very little water to support our sanitation systems, unlike the flushing of our toilet, which uses quite a lot of water. So there are different drivers for these things. Now, the last thing I wanted to talk about is, my presentation title was, the need to rethink infrastructure. But for me, while we rethink infrastructure design and business models, there's another powerful shift underway. And it's not in the pipes or the pumps, but in our data. And this shift could transform the way we understand, predict, and manage our water systems. So one of the most exciting shifts that we're seeing within the IWA and within our sector is the rise of not digital. I mean, we've done a lot of work on digital innovation, sensors, machine learning, and smart devices, and we've got a big program on that within IWA. But what we see now is the rise of generative AI, or large language models. And it's really ushering in a new era of data-driven insight. These advanced AI systems, they unlock the value of our untapped data, making complex analysis simple and accessible. Gone are the days that a utility would need to hire a programmer to analyze all of their data. Now, all of you are programmers, right? You can just write in English or in whatever language, and you can do all these clever things that in the old days you'd need hardcore programmers to interrogate and do that sort of stuff. And generative AI can integrate, another really interesting part of it is that it can integrate all types of data formats, structured, unstructured, and also tacit. So we can put in monitoring data such as pipe flows and pressures, the asset management records from our sort of asset management systems, that would be structured data. But we can also put in things like customer complaints from our CRM, and even take the knowledge that would be unstructured, and then our knowledge from our experts who work in the field, we can somehow capture that through interviews and things, and it can process that. So it has this potential to process all of this information pretty seamlessly, and we've been testing this out, and we're seeing a lot of potential here. But first, one thing I want to share with you is this sort of truth. You see, utilities, my experience of working with utilities is that they are not short of data. They're actually drowning in data. Do they use that data is a different thing, but they have a lot of data. And if you think about a utility's data like a library, it's a goldmine of insights. Yet most of the books in a utility data's vault are hardly ever open. The utilities have been collecting data for decades: historical registers, handwritten logs, contractor records, system performance metrics. But the volume and complexity of this data is overwhelming, and a lot of it is left unused. And the challenge for me is not the lack of data, but it's data blindness. And just imagine if we could unlock some of this data and start interrogating it. Now, today, it's quoted, this is a very general sort of statement, but generally the water utilities use about 15% of all the data that they collect. And it tends to be very clean, structured data that's very easy to analyze. And this includes sort of things like real-time flow rates, pump performance, and billing data. And this is the data that sort of drives their dashboards, right, and their alert systems. But this 15% of data is very reactive. It tells us what's already happened. A pipe's failed, pressure's dropped, rather than predicting what might happen next. To move from reacting to anticipating, we need to tap into the 85% of data that we don't use. And for me, this 85% of the data is like the graveyard of missed opportunities. It's not useless, it's just untapped. It includes structured data, like remote sense reading and historical pump failures, but it also includes unstructured data, like handwritten maintenance logs, contractor records that expose good workmanship and bad workmanship, customer complaints about water quality, and emails from engineers flagging recurring problems. Hidden inside all of this sort of stuff are potential patterns. You know, we might be able to say that a certain pipe always fails during the rainy season. We might be able to say that a certain pipe material tends to underperform very regularly. But all of this remains unanalyzed. So unlocking this 85% could be very powerful for our sector, and we're already working with countries in India and East Africa in trying to unlock a lot of this data that they already have. But data isn't just what we record in systems. Some of the most valuable knowledge lives in the experience and intuition of our people in the sector. When you think of a library, you have the books, right, that hold the facts. But the librarian, they know what the real gems are in the library, and they know which books matter the most. In our sector, the librarian is the veteran pipe fitter who can sense a leak before any sensor can. It's the billing clerk who can spot unusual patterns long before the system flags them up. This tacit knowledge, built over decades of field work and mentorship, rarely make it into our databases. It lives in the stories and conversations and the hands-on experience of the people that work in a utility. Now imagine if we could capture and analyze that wisdom. With generative AI, you can turn the recordings and the interviews and the field notes into searchable, actionable insights, making sure that the expertise of today's librarians guide tomorrow's decisions. So if you imagine, and this is the sort of model that we're working on, so you get access to your 15% of structured data, your 85% of other data. You then get your tacit knowledge from your workers, the people who really run the system and work the system. And then you can ask questions in English. You can say, look, what types of water meters do you prefer? And why do you prefer them, right? Is it cost? Is it because they're easier to install? Is it because you just like them? And then, by analyzing the rest of your data, you can compare these preferred water meters that the operators have with the actual performance of these meters. And you can start to do a sort of analysis, and you can correlate, and you can start to make decisions. This sort of stuff we always wanted to do in the past. We just didn't have the human resources and the capacity to do. But now it's very easy for us to do. And those of you who worry about things like generative AI, what we're talking about here is only asking it to interrogate things that we put into it, right? It's not going into the wider internet and hallucinating. You're limiting the domain of its search to the information that you've put in, which you trust. So if you take pipe condition assessment, this was an area where I did a lot of research when I was an academic. This is where we try to understand the condition of our pipes under the ground and then decide on how we rehabilitate our systems. Traditionally, we've used structured data, right? Pipe material, pipe age, this type of information to estimate how pipes age under the ground. We're now starting to use a lot more of the unstructured data, things like the quality of the contractors. I did some work where we found a certain section of the network was failing regularly, even though it was relatively new pipes. And it was very hard for us to realize that it was actually the contractor who was at fault. So all the pipes laid by a particular contractor were failing. You can combine that information with things that also affect the condition of the pipe, the soil conditions, the weather, because the weather changes the external forces on the pipe wall, and then traffic loading affects forces on the pipe wall. You can then combine that with tacit knowledge from your operators, the people who actually work the system, and then you can feed that into a pipe condition assessment model. And you can couple that with your hydraulic models. The hydraulic models will tell you which pipes are the most significant in your network, which ones have the highest hydraulic carrying capacity. You combine that with this, which tells you the pipe condition. That can then inform which pipes you should repair and when. So it's not depending entirely on generative AI, but it's combining that with your mechanistic models or your data-driven models to give you these insights. I always end with this slide. I know I've spoken a bit over my time, but I always end with this slide. And it's really a slide that tells me one thing, right? Our sector has no option to stay in the business as usual lane. You know, the external pressures that we're facing, that's a no-go. And if we were to build our systems from scratch, we would never have built the systems we built the way we have. We wouldn't use drinking water to flush our toilets. We wouldn't use drinking water to water our plants. Right, if we had the chance to go back and start from scratch, we would do it differently. Now, most of our utilities are in the middle lane. They're trying harder. They're trying to retrofit their existing infrastructure and trying to respond to some of these global change pressures. But where I see the big opportunities, and I'm seeing it in my travels, is in countries where they're just starting to build this infrastructure. And they are reimagining how they want to do water in the future. And they are really going to create the change that all of us will follow in the future. And as I said at the beginning, it's the young, right, that are going to make the difference. Because you're not tied into that sort of 19th century thinking that underpins all our current water infrastructure. You'll start thinking more in the 21st century about how we can do business. That concludes my presentation. Thank you very much.
For your nice presentation and for all the perspectives you explained. And now we would like to invite you for a talk.